Hi, everyone. Welcome to Conveyor Meetup. Today we have members of the community, Marco Berube and Eric Nelson, who will be presenting on the newest release that the community has. So before I hand it over to them, just want to go over a few housekeeping rules. Mostly, I will send out the slides probably within a day or so. And then if you haven't heard, we're having a hack fest for the community at the end of January. So if you're interested in learning different use cases around modernizing and migrating to Kubernetes, we suggest you join. You'll have the whole community support there. And at the end of the day, you're helping us also improve the tools that you can then later use for other projects. So with that, Marco, I will hand it over to you.
Hey, thanks, Jonathan. Let me share my slides. Jonathan, can you just confirm that you can see this?
Yep, you're good to go.
Thank you. So today I'm going to be talking about rehosting applications between Kubernetes clusters using Crane. My name is Marco Berube. I'm the product manager for migration toolings at Red Hat. And Crane is a new project that is actually related to a current tool we have inside Red Hat. It's called MTC. But Crane is this new upstream project that, like, based on everything we learned on MTC, like it's actually going to help us like increase the scope of what we can do from a migration point of view. So from an agenda point of view, I'm just going to quickly go over what is actually Crane, some of the use cases, the introduction to the Crane commands and how the tool works. And then Eric Nelson, which is the engineering manager for this tool, is going to go through a more deep dive demo of the tool and how it works. And and we'll go from there. So, and let us know if you have questions, and we'll answer questions at the end with some Q&A. So quick update on Crane. So Crane is a project in the conveyor community, as you might expect. But it's to help migrate applications from all kinds of Kubernetes flavors to Kubernetes or OpenShift. So just want to point out that actually MTC 1X is not Crane, right? So MTC was built, and we started the MTC. So if you're familiar with MTC, which was the downstream Red Hat project, which was called Migration Toolkit for Containers, or MTC for short, this tool was built for OpenShift to OpenShift migration only, and mostly for the purpose of the Red Hat customers migrating from OpenShift 3 to OpenShift 4. But as we've been working on this for a significant amount of time and did a lot of migrations, we learned a lot, and now we're kind of re-implementing this knowledge of everything we learned on that tool in this new upstream project Crane, that we hope is going to be built on like all the latest and greatest and everything we learned to make this tool even better, and with a bigger scope, which is any Kubernetes to any Kubernetes flavor migration. So Crane doesn't have a downstream product name yet inside Red Hat. So right now it's just an upstream project, and but we expect that will happen later this year, and have something also downstream, as everything we do upstream becomes a typically like a product downstream. Then that should happen around spring 2022. But stay tuned for what this will be named and how this will be delivered. But for now, let's talk about the upstream Crane project. And Crane right now, the expectation is will be a mix of some command line power tools, or a way to do more advanced type of migrations, and in the future also could be leveraged with some kind of downstream, like OpenShift easy button type of migration, as we want to make this actually part of the OpenShift product in the future, as a way to easily migrate applications between OpenShift clusters as well, using the same technology. So let's talk a little bit about the lesson learned, right, from all the work we've done so far with this engineering team for 2 years now, and some of the most requested features that sometimes we couldn't deliver in an MTC fashion because of the way we actually started this project and the current architecture or limitation that we had and the way we build this tool. So the first one is the admin requirement. So today, one of the issues we've been having with MTC is you need cluster admin privileges, and we heard loud and clear from many people that actually they wanted their developers or app owners to do their own migration. So this is one of the key thing we want to solve with Crane, is to allow developers or app owners or people without cluster admin privileges to actually migrate their own application. Another thing is I would like to provision this application from pipeline, but only migrate my state. So this is something we've actually solved in MTC, but something that is going to be even easier to do using the crane commands, so that if you want to reprovision from pipeline, but only using this tool to migrate the state or your PVs, then you will be allowed to do that pretty easily using the crane tool. Also, one other thing we found is in the first place, like, and I'll touch on the next slides in more details, but technically, like in many cases, you should not need a migration tool, right? Like if you would have automation, if you would have automated deployments and pipelines, then you could just reprovision this application to another cluster. But if you don't have that, like how Crane could help you actually achieve that? So as you are migrating from one cluster to another, like the current version of MTC, like it's helping you migrate from one cluster to another, but your end state is the exact same state as you were on the first cluster. You're now just locked into another cluster. So with Crane, we want to automatically help you build some automated deployments and following GitHub's methodology, so that at the end, after the migration is completed, you are improving your situation. And we also want to make sure that this is as easy as possible to troubleshoot. We made significant improvement over the years with MTC, but still, we believe that with Crane and the current and the new architecture is going to be even better and easier to troubleshoot anything that could go wrong during a migration process, as we understand that like you could have downtime, and this could be in a maintenance window. So anytime we can save troubleshooting and fixing issues is actually a very good thing when you are migrating applications. So that's one of the other key things we're thinking about while building this project or this new architecture for Crane. So again, as I touched on the previous slide, but why do you actually even need a migration tool in the first place, right? So if you have automated deployments, then obviously migrating from pipeline is the best approach. So, but we found that many applications don't have that, and this is why you end up having a need for a migration tool. Also, even if you have automated deployments, you might have state. So if you want to provision your applications from one cluster to another, but you need to migrate your state, this also could be another reason why you would need a migration tool to help you with that, to migrate the data from one cluster to another. And this is what we found like so far over the years. That is the current situation with a lot of customers that we're seeing using Kubernetes. So typically, like over the years, you've had installed and deployed many applications, and some of those applications and a small subset will have some automated deployment, right? So this is like typically that would be your most important apps, and those ones would have a way to, you would get automated deployments and will be promoted from dev to QE to production. But there's a larger subset of those apps, and we've done surveys like with also in previous sessions, right, asking like the percentage of your application that have automated deployment versus not having automated deployment, and this is pretty good ballpark in many clusters or customers that we're seeing today. So the issue is that all those manually deployed applications becomes pets, right? And they have hard-coded information, and which can be IP addresses and metadata information specific to the cluster they're running on. And this is what make them pets and make them very difficult to actually move from one cluster to another. And as soon as this cluster that you're running it on, you need to, for some reason, upgrade it, or you want to migrate those apps from on-premise to the cloud or from one cloud to another, that makes it very difficult to embrace this hybrid cloud approach, as you are locked in with all those manually deployed apps. And this is one of the problems we want to solve, right? As right now, even if you can, for example, reprovision from pipeline your application that have automated deployment, and then you could use a migration tool to migrate your apps that have been manually deployed from one cluster to another, the end state is still the same. You have the exact same configuration that you had before. Where we want to get you to is, after the migration, create for you some automated deployment so that in the future, you don't need a migration tool. You have automated deployments, you have, you're following a GitHub's approach potentially, and this will allow you to now be more agile and to promote code from dev to production in a much faster way, as you will have the proper approach of deploying applications on top of Kubernetes. So if we think about how a migration tool works, right? So, and this is the scenario one, like the most simplistic like migration pattern. So first of all, you need to extract all the Kubernetes manifest and re-import them on the destination side. And in many cases, you have to fix them as they might have metadata or all kind of things in those manifests that actually are proprietary to your source cluster. Then you would have to migrate the state or the PVs from one cluster to another. And then you have the images as well. So as a first use case, you could use Crane just to simply do that, right? Which is also what MTC does today. So you would use the Crane command to migrate all those three things very simplistically. And then this scenario two is you can reprovision from pipeline on the destination side, right? So you have all your stuff in Git and you have a CI/CD solutions. And then you can use Crane to migrate your state. If you have a database with some data in it, and if you have all kind of, if your application have data with live like important information for you, then you can use the Crane state migration command and reprovision from pipeline. And if you don't, and if you are interested in actually improving your situation and have automated deployments in the future, then you can use Crane as well to reconstruct your manifest, but instead of provisioning that to your destination cluster, push that to Git, and to have your CD solution to reprovision that on the destination side for you, which at the end will bring you to a much better state as you would have automated deployment. So Crane can extract your Kubernetes manifest, clean this up, push that to Git, and then leverage your CD to deploy that on the destination side. And the most simplistic way, and there's many ways to use Crane, and Eric will go through into more details, but if you would use the most simplistic way of using Crane, you would see something like Crane export, Crane transform, Crane apply. Those are the commands that you would use to actually do those steps and to provision your manifest into Git. Then you would have the Crane transfer PVC command that would transfer the PVs from source to destination. And yeah, that's it. So I'll stop here. I'll let Eric provide more details about how this tool works technically from a demo point of view. Eric, are you there?
Hey, everybody. Can you hear me okay?
Yes, we can.
Cool. All right. So I'm sharing my screen right now, and I'm looking at a project within the conveyor org called Crane Runner. I can get more details what exactly this is housing, but as what's interesting and relevant to this call is that we have a set of examples that are inside of this that we'll also be publishing to our Crane documentation. If I can drag this over here. This is our documentation site, so I'll provide links to that, and we're going to add some scenarios for folks to be able to follow along what I'm going to demonstrate today. I'm only going to go through one of the most basic examples and show kind of each of the steps that Marco was just describing. But we have this sequence of scenarios that folks can run through that gradually kind of ratchet up the complexity to demonstrate one particular piece or use case of the tooling. Because as you mentioned, this is kind of a toolbox of different utilities that can be combined in order to do like more sophisticated things rather than one prescribed path. Although downstream with Red Hat, we're going to have an opinionated solution that will help you with, as Marco described, like kind of the easy button. So we're going to try to go through this like stateless application mirror. So we're going to be using an example application called Guestbook. That's kind of the classic Kubernetes example. That's not a total toy application, but is also like, it has a Redis backend, and then it's also got a front end, and it's got a bit of stator it's designed to, and some of its iterations as a guestbook application. So it's kind of your hello world application. Next, the scenarios include a section on how do you integrate this with Kustomize. So once you've stripped everything out of it that's cluster specific, so that it's no longer this pet application, how do you layer back in details that are relevant? Because sometimes you actually need to layer things back in, such as resource quota information or node selectors that are actually specific to your destination cluster where you want to deploy your application. Number 3 has the GitOps integration demonstration. So in that example, you actually integrate with Argo CD in order to on-ramp yourself into a CD situation so that Argo itself is actually deploying rather than you directly. And then finally, there's a couple stateful application examples. So migration, and then there's a stage in a migrate model where you can continuously stage your data over time while keeping your source applications up. And then finally doing a final cutover migration so that you minimize your downtime and you can get the bulk of your data onto your target cluster while only capturing the deltas that have been written since your last stage during the final migration. So I'm going to jump into the stateless application mirror. And so I'm actually not going to be following this exactly because this is using Tekton, which is a pipeline project, native pipelines for Kubernetes. But we're going to be using some of the commands that are in here. And we'll also be adding a Crane 101 scenario to this shortly. I think there's actually even a PR out there to add that. But so the first step that we have is in my environment, I'm going to be running a couple of Minikube clusters. So this is a really convenient way to get started. You can bring a VM like a RHEL or a Fedora VM. Maybe you launch it in EC2. We've actually tested that and have some documentation around recommendations for that. But I'm just going to be running on a box that I have at my house. And what this script does is it actually launches two different Minikube clusters on the same machine. I'm going to be using Podman as my provider. And it's got some networking rules that are necessary for routing as well as DNS in order for both of those clusters to be able to see one another. So, and I can point folks to this. So if you want to take a look at exactly what this is doing, there's kind of some guards in place here, but it's for the most part, it's doing as I mentioned. So we're bringing up the source and destination cluster and setting up the networking. So I actually already have that set up in this environment. So I'm in my machine. This is a Fedora machine that I freshly set up and installed Podman on. So I have a couple aliases. MK is my Minikube. I use a couple tools. k8s is a tool called Kube Context. That's really convenient for switching between Kubernetes contexts. And then KN is my KubeNS tool. So it's related. These are like bash scripts that get loaded. And that'll help me set like my active namespace. So this is kind of a function that is nice and part of OpenShift that we don't actually have kind of natively in a similar manner. So this helps with vanilla Kube environments. So right now I'm going to set my context to my source cluster and go ahead and get started. So I'm going to skip over installing Tekton because we're not going to use it in this example. And then I also am not going to be installing Crane Runner manifests because again, those are cluster tasks that are related to Tekton. What I am going to install is my example application workload. So I'm going to run a command to create my guestbook namespace on the source side. And then secondly, what I'm going to do is run a customize command that pulls in the guestbook application and installs it on my source cluster here. So the customize command is just layering in some details. I think it's bundled as a customize, which means it's organized in such a way that it's customize aware. And so this instantiates it, and then I'm going to pipe it into my kubectl command to create that on the source side. So now you can see that my active namespace is the getbook, and if I run a get pods here, they're all actually running already. Under normal circumstances, you have to pull this, so it takes longer. I actually ran through this already once, so I've got all the images on my machines. So fortunately, we can benefit from that stuff coming up quickly. So I've got a front end, a Redis master, and a couple of Redis slaves. So this last command will just block until everything comes up as ready. This doesn't happen to be ready. So now we can get ready for our application mirror. So now what I'm going to go do is create a namespace, a guestbook namespace on my target cluster to house the guestbook application. So my goal here is to mirror this application onto my target side. So at that point, we should be ready to actually get started using Crane. So you can go find Crane in conveyor Crane, and we have a sequence of releases here. Our current release is Alpha 2. We are expecting an Alpha 3 release pretty soon here. But with each release, we'll have release notes, and we're adding new features as we go along. So you can download, this is the binary directly. So it's a Go binary, doesn't need any dependencies. You can download it, make it executable, and then it should be available to you to use. So I've added it to my path on this particular machine. So if I run a Crane version on here, you'll see that I'm using Crane version 003, and then I've got a crane lib, which is where a lot of the logic is implemented, so it can be utilized by other projects, as 005. So crane itself, the command, has several commands that you can run. The ones that we're interested in today are the primary migration commands. So that's going to be export, which exports the raw application resources that it finds within the namespace that you specify to disk. And then secondly, we're going to run transform. So transform is the piece that generates a set of JSON patches as dictated by the plugins that you have installed. We use a plugin model because I'll just describe a little bit of background around this. It's pretty frequent when you're approaching different environments that everybody's kind of got one-off problems. And so in an effort to build a generic tool, but one that also services people with specific needs, we've decided to build this around a plugin model. So the cool thing about that is if folks end up discovering particular issues for themselves, or they have like really specific needs, the plugin API is very simple for folks to go out and build plugins for themselves to solve their own issues. And then secondly, they can go and actually pull down plugins that have already been written so that the community can codify the solutions to those problems within plugins and share them so they're easily accessible to the rest of the community. So the crane command itself actually ships with a couple of default, well, actually it ships with one plugin that's built into it. And then secondly, it has a default repository where we are publishing kind of our official plugins. So the plugin that's built directly into Crane is the Kubernetes plugin. So there's a whole set of like cleaning operations that we know already are going to be necessary for Kubernetes. Things like owner references, stripping like derivative resources from owner references. So an example of that would be a replica set in a pod. What you actually want to do is restore the replica set on the target side rather than actually and allow the target cluster controllers to recreate those derivative resources, such as the pods. So we want to strip those from your manifests so you're not recreating those. Trying to think what else. So that's kind of an example of a Kubernetes transform. A second example is once you get into OpenShift, you start to talk about routes or OpenShift specific resources. And so there's operations that you want to include there. However, it's an optional plugin, so you can decide to use it or not, depending on whether or not your target environment is an OpenShift cluster. And then, of course, you can get more and more specific, so you can build plugins for things like node selectors or your own specific environments. All right, so I'm going to get started here. Let's go into my working directory. I think I have a demo directory. I've run this one time previously, so I'm going to rmrf that whole directory just to start clean. And so we're starting clean, and I'm going to set my context to the source cluster, and I'm going to set my namespace to the guest book. I think it was already done, but I'll just make sure of that. So we'll start with crane export. I'm realizing I'm actually forgetting the third command, which is apply. We'll talk about that when we get to it, but it's effectively the application of the JSON patches that are generated against the raw resources to produce your output, which is a cluster agnostic set of manifests that can then be recreated. So crane export itself exports the raw resources. So you can see it's going in and it's actually using the Kubernetes API server's discovery API to understand what are all of the all the API resources that are available. And then from there, it'll go through and it'll make sure to export that. So the cool thing there is that it'll actually support CRDs as well, because it'll be able to find those based on the discovery API. So I'm going to run a tree here. And so you can see these are all of the raw resources that it just found within my guestbook namespace. So I've got things like underlying pods that have been generated as a result of replica sets. I've got endpoints and endpoint slices that have been generated as a result of the services. And if I go and look at one of those, I'll take a look at let's look at the Redis master here. You'll see there's cluster specifics here. So I have an IP address, and that IP address may not be relevant within a target cluster. So it's cluster specific information that I'm going to want to strip before I version it and get that into something like a CD system. So, okay, so now I've got my raw resources, and that can be useful in itself just for exporting your applications and the resources that make them up for your own purposes. But now I'm actually going to run a crane transform. But before I do that, I want to take a look at the plugins that it's going to run. So I'm just using Crane, the default binary that I downloaded. I haven't installed any custom plugins, but what I actually do have is there's a plugin management command here so that it can discover plugins and you can easily install them. And then lastly, so you can run a list plugins command when you do the transform command so that the tooling will tell you, hey, these are the plugins that I'm going to use when you run your transform command. So we can run that now. You can see the only plugin that I've got right now is the one that's baked into Crane, and that's the Kubernetes plugin. So this will perform all of the logic that we know that we need to do when we're doing a Kubernetes migration. So I'm going to run Crane transform right now. Most of the default arguments are acceptable to me in this scenario. There's a lot of configuration that I don't really want to get into right now. So you can see here that a lot of work was done here. One of the examples here is that like the underlying endpoints, because these are derivative resources of a service, those are going to get whiteout files. And what that means is that they're going to get blocked when I do the application of these transforms, so that they're effectively stripped from my output set of manifests, because I'm not going to need those. Similarly, I'm going to have the same thing with pods. So we can run a tree command on transform. And so here are the JSON patch files that I've got. So let's take a quick look at one of those. Probably looking at the Redis master is helpful. So here are the JSON patch commands that it's going to run. And these were all created as a result of the plugins. So it's going to do things like strip my metadata. The status is no longer relevant once I version it. So it's really just kind of cleaning up these exported resources. And then another item here is, I'm sorry, I'm looking at a deployment. We're going to want to strip the cluster specific IPs from these services. So here you go. So you can see here we remove a cluster IP because we know that that's not something that we want to get created once we instantiate these on the target side. So I've got this set of whiteout files plus my JSON patches in order to manipulate my raw exported resources to turn them into a cluster agnostic manifest. So the next step is to run a crane apply command, which is going to do that. You can kind of think of this as, I have like kind of a useful function here. If folks can see this, apply is really, you can think of it as an idempotent function, meaning that I can rerun this over and over and over again. And as long as my inputs are the same, my outputs are the same. This also doesn't have any side effects, so it's not going to be impacting the applications that are running inside of my clusters. It's all happening on the command line and in my local environment, which in our experience is kind of paramount when you're doing these migrations. You really want to be careful about altering the state of your clusters so that if things go sideways, you understand what happened and you're able to recover from that in an easier manner. So this is going to take my raw resources as an input and the transforms that I just showed, and I'm going to get a cluster agnostic output. So if I run crane apply here, it does just what I mentioned. And then if I run a tree on the output, you can see a bunch of those resources have been stripped. And if I actually show this side by side, we can compare the raw resources to the exported resources. So this is the raw output. And then on the left-hand side, I've got my stripped set of manifests. So there's quite a bit less on the left-hand side. And that's because, again, a lot of these are generated as a result of kind of the parent objects that are over here that make up my workload. So now what I'm going to do is go ahead and I'm going to apply these to my target cluster. So I'm going to set my destination context to my dest cluster. And so if I run if I list the namespaces here, actually, we did create the guestbook namespace because I needed destination location namespace to put those in. And if I get the pods, there's nothing in there. So I don't have anything in this namespace. It's a fresh namespace. Just going to pause for a second. I see a question here. What plugins do I need when I move an app from GKE to OCP? I think that's what it says. It's blocked. Is there an OpenShift plugin? Yeah, so the answer is yes. Because you're going to OpenShift from GKE, you'll want to use the OpenShift plugin for that. Once our product goes live within OpenShift, it will be designed in order to do that. So you can just take the defaults and the OpenShift plugins already installed. If you would rather use the CLI for doing that manually, and there are a lot of reasons to do that. You may want, you may have some more advanced use cases, or you want, finer grained control over what you're doing. You'll want to install the OpenShift plugin, and there is an OpenShift plugin. So I guess I can show that really quickly. So there's the plugin manager command, and so if I list the plugins that my plugin manager knows about, you can see that because of the repositories that I have installed, I have an OpenShift plugin that's available to me for install. And that's available upstream as well. Okay, so we left off trying to recreate the cluster agnostic manifests that my apply command had output in my destination cluster. So really we're doing like a basic mirroring of an application workload from the source to the destination. And that's going to be as simple as a kubectl apply. So if I go to my guest book, I'm going to apply this directory. So this is just going to cause it to create, well, actually apply all of the objects that are found within this. So you can see that all these got created. Some of these default service accounts already existed there, so it's just complaining that they weren't already created by apply. So these are safe to ignore. So I'll just make sure that I'm on my destination context and in my guest book namespace. And if I do a get pods, you can see that that has launched my application on my destination namespace. So that's kind of the most basic of examples, but as Marco described, like there are definitely much more complex use cases for this, and it's really flexible. And one of our favorite parts about it is that it's all been designed to be very transparent. Migrations can be ugly things, and so the ability to be able to diagnose problems when they arise is really important. So that's kind of it's been designed from the ground up in order to make that make sure of that. See another question in here. Do plugins only apply to the destination environment then? No, so plugins will do, they'll do arbitrary mutations upon your exported resources. So the way that we've kind of been thinking about this is that the plugins often are pulling things out that are cluster specific, whereas you can marry this with customize in order to overlay cluster specific details of your destination clusters back into your resources. So an example of that might be node selectors. So the nodes and the way that they're labeled are often cluster specific. So if you would like to set up a node selector for your application as it gets layered in, or as it gets deployed to another destination, you can use customize in order to overlay those details in. And customize is natively supported by things like Argo CD. So you can even combine customize with CD systems like Argo in order to overlay those depending which cluster you're going to. Yeah, I hope that answers your question. Feel free to ask for clarification if that didn't. Jonathan, I think that's it for me.
Awesome. Thank you, Eric. So guys, that's it. So I did put a link to a forum, and that would help us understand like how helpful this content was to you. If you do have any questions, there's still time to put it in the chat. I think another one just came in for you, Eric.
Sure. How would one do a migration if the source cluster is a database to the destination database with all previous data? So I'll answer that assuming that you don't already have a database on your target side. I'm not sure if you mean like, can you merge data in the target side? I'm assuming that you don't mean that. So we didn't get into the stateful piece of that on this call because we really didn't have time to, and it probably deserves like several of these meetups in themselves because it's complex enough of a use case. The stateful component of this is really kind of the difficult part when it comes to migrations. So if you're curious, you can actually run through some scenarios that will demonstrate that in this in this Crane Runner repository. Let's see here. So we have stateful application migration and then stage and migrate. So It depends on whether or not you're already in some kind of a CD system or you want to go to a CD system. Let's assume you already have kind of a pet application on your source cluster, because that's the most common scenario, and it's got a database. So and that database is on the cluster, because often people will have external databases that are off cluster. So the interesting one is the database that has its state also within that cluster. So as a sequence of as a sequence of commands, and the order is relevant here, you'll be able to do something like transfer your PVCs using a crane command that we didn't get into here, but there is actually a transfer PVC command that will help you map PVCs from your source cluster to your target cluster. So what you'd be able to do in the case that you have a database is basically launch your namespace on the target side and then use transfer PVC to get most of your data onto the target side while the application is still up on the source. Then you can export your application details, quiesce the application so you no longer have new data being written to that database, and then run through the export, transform, apply to get your workload resources over to the target side. Do a final data transfer PVC, which is, again, it's also, it can be rerun over and over and over again in order to pick up the delta. So in theory, that one should run much faster than the initial one because it's only picking up any of the new data. And then you can bring up your application on the target side. So we can get into kind of those advanced use cases, but we're thinking about that a lot. And so that's one off the top of my head, that's how I would approach it.
And we actually got a couple more questions in here, Eric. So the next one is, I assume migration is possible with Crane if target cluster is not connected. Is that correct?
That is correct. So there's some like gotchas around state transfer, because state transfer depends upon the clusters being able to see one another. However, we also have some tickets in order to explore what it would be like to actually export your data off of the source cluster and then use like a sneaker net mechanism to like get it into your disconnected cluster on the target, so that it like, maybe you want it on your workstation or whatever. But yeah, Crane itself, so you can see that I was actually operating on my workstation. So you can it exports all of those resources onto your desktop or wherever you're running those commands, and then you can use that as long as you take your laptop into your disconnected network so that you can see that cluster. Then you can actually create it. So that there's a way that you can kind of operate with disconnected.
And then the next question, Eric, is how does Crane handle scenarios where the k8s application are being run as root and we need to migrate it to OCP?
That's a great question. We've been thinking a lot about that as well. On some level, some of these applications are actually like themselves written fundamentally to expect root. And so that's like tackling that problem is a little bit outside of our own domain, although we can make a best effort. So for example, like if it fundamentally expects root, like there's not a ton that we can do about that. And that's an application detail that has to be addressed. However, there are also a lot of other like, one thing that comes to mind is like pod security policies, which is a Kubernetes resource, and the analogous resource in the OpenShift world is an SEC. So we've been thinking a lot about like, this is a complex issue, as you can imagine, but there are kind of transforms and like permission control features that we can implement in Crane in order to address that. So yeah, it's recognized that like OpenShift often is kind of a more strict environment. And so we're adding the tool sets in order to allow you to integrate with it.
Thank you, Eric. And then the last one that we have so far, and I don't know if this is for you or Marco, how does Crane migration differ from the MTC tool in OpenShift? Marco, I'll bring you on just in case you have anything you want to add.
Yeah, so right now the only downstream product is still MTC. Crane is more, for now, is only upstream. As I was saying in some of the slides, like Crane, we expect to have something downstream in spring timeframe. And the idea so far is it would be part of like in an OpenShift feature more than a product by itself. So we would like to bring this in a way that like eventually over time you would have like some kind of tool inside OpenShift that can help you migrate. So, but there's a lot of things that need to be figured out before we can talk exactly on what this will exactly look like in the downstream. More to come in the next couple of weeks on that.
All right. Thank you, Marco. And it looks like that's all we have for today. So everyone, thank you so much for your time. And remember about the Hackfest. I put the link to that up top in the comments. So other than that, we'll see you next time. Bye, everyone.
Thanks, Jonathan. Thanks all. Bye.